the water into them, we give them that carboxylic acid tail. That carboxylic acid tail allows them to interact with that water layer so that they can go through. One of the ways that we take these fatty acids in is to diffuse them across the membranes in a gradient. We cannot pass this water layer unless we have some sort of hydrophilic component. Free fatty acids, carboxylic acid groups, super hydrophilic, super acidic. They will go through. Our other option, once we're left with this 2-monoacylglycerol, right? We have carrier-mediated transport, and this particular molecule also has a way to cross the barrier. So that's the point of this section. How do we do that? We use gastric lipase. We can take one of the fatty acids off, and then we're left with a diacylglycerol, which we can then attack later. We have, and we can also bring some DAGs across. We have, but we get that free fatty acid, right? That carboxylic acid group. And I keep going like this, like I'm some sort of alligator, because that's the shape of the bond at the end, right? Okay, so we've got some free fatty acids. That digestion process is beginning in the stomach. So in addition to that, we take pancreatic lipase and we break 2 fatty acids off in the top and the bottom positions once we get to the small intestine. We break those off so that we've got these free fatty acids with these carboxylic acid, and so we can bring them across the water. We also have these monoacylglycerols, which we'll talk about bringing in a second. We are trypsin activated with the colipase as protection. If we're sitting right next to that brush border membrane in that water layer, we have the possibility of autodigestion, right? We have lipid membranes all over the place. If you have an active enzyme that's just constantly active running around and it has targets, it can randomly use them. So if we don't activate until trypsin is released, trypsinogen, which then gets activated to trypsin, then that pancreatic lipase, once that colipase is no longer activated, is not capable of working as an active enzyme and popping fatty acids off of anything that might be hanging out. Does that make sense? Okay, so this whole part is how are we breaking this stuff down so now we can talk about getting it in? Because we need these fatty acids, so we're going to talk about putting them in the enterocyte so then we can send them out to the rest of the body so we can make things.
Can you go over again